Welcome to wasmCloud Wednesday for Wednesday, April the 13th, 2022. As usual, we like to get started with a demo. We're going to hand it over to Steve here so he can give us a tour of what he's working on.
Awesome. Can you, I'm trying to share. Oh, got it. Okay. So this describes a model that I've been working on with Christoph Brewing at BMW. There are three actors in this picture, the circles, and a capability provider that runs a machine learning inference engine. And there's also a bindle server that serves the models. So the capability provider can work with ONNX and TensorFlow models. And we have a couple of, some demo models in the repository that are useful for just testing, kind of returns the identity. The API in between, the horizontal arrow between the inference API actor and the capability provider is based on the wasmNN interface developed by Intel and a bunch of other collaborators. So it basically sends a tensor, which is a multi-dimensional array, over to the inference engine, which runs a pre-trained model. For image processing, we need to do pre-processing before we can develop that tensor. So the pre-processing takes a JPEG or a PNG image, converts it into the right color space, scales it to the right dimensions. And so that's done by an actor-to-actor call. That's the arrow going down and left from the inference API. And then it sends the tensor to the provider. When it gets the response, it does some post-processing. And the post-processing for the image recognition model is to compare the image against, the model compares the image against known images and tries to recognize what is this a picture of. The post-processing turns that into English so we can read the picture names. So now I'm going to switch to terminal window. And right now it has a HTTP interface. So I'm just going to run curl. Oh, first I'll show you images. So we have an apple, bird, bunch of images there. So I'll send the apple over, and it compares it against the images, and it was a green apple. So it decided that's a Granny Smith apple with a probability of 95%, or maybe it's a fig with a probability of 1.5%. So we can do some other, we can recognize a hot dog, recognize the hot dog picture with a probability of 99%, or with less than 1%, it might be a French loaf or a spaghetti squash. And so just so you can see what the picture is, that's what it looks like. So that is the machine learning provider demo. It's currently checked into Christoph's personal directory. It'll probably get put into an examples folder soon, but it's definitely ready to play with, and you can add some models. One of the reasons why we chose to run the capability provider, run the inference in a capability provider, is so that you can host it on a machine that's got a beefy CPU or GPUs. There is interest in being able to run a pre-trained model inside an actor. Then it could be run on a browser, and that's something else that we want to work on in the future. Are there any questions on this before I go to the next topic?
Steve, this is
I
great. So you're demoing today. This is are these TensorFlow or are these Onyx models that you're demoing? Just out of curiosity.
I think this is Onyx. The model is actually, this image recognition model is actually MobileNet, which is a well-known model that's often used in small constrained devices. It doesn't have as rich of a database as ImageNet, but it works really well for pictures. It has 1,000 images that it compares against. So you can't get too obscure. So Liam, the answer to that question is it could be either Onyx or TensorFlow. Those are different libraries for loading the model. In this case, the model that does the recognition is MobileNet.
100%. Okay. And then one question I have is, if I'm, when we are using TensorFlow, are we just using like the standard TensorFlow as the on the other side of the capability provider as the provider here? And the reason why I asked that is that when we were talking to Intel, they said that they've already included, all the optimizations for even their CPUs already baked in. So is this like standard box TensorFlow on the other side of the capability provider?
Yes. So this runs, so as the capability provider, it's compiled natively against the TensorFlow libraries. So if you install the Intel extensions for TensorFlow, then you would get those extensions as well. And so those Intel extensions are take advantage of CPU instructions in Intel processors that accelerate machine learning models. There's a link to that in the README for this repository. There's also a segue to the Python capability provider, which was the next thing I was going to talk about.
Sure. Any questions or comments? There's a few things mentioned here in the Justin. Did you want to chime in on this, on your thoughts, or anyone else in the call?
No, on my end, it's just premature optimizations. Obviously, he's demoing that it can return multiple results at various probabilities. I'm just saying, improve that by dropping anything below a certain margin of error.
Yeah, we definitely should drop it. It limits the results to the top 5, but we should be top 5 and more than some percent threshold. I completely agree with that.
There's a common data set used that's open. It's the Iris data set, which will still give you some of these higher probability results that might be more, I don't know, less likely to get critiqued, I guess, in the moment.
Okay, I'll take a look at that.
Well, I think ultimately, I think there's this is just opening yet another door of exploration here, and gives you a ton of power and capability for building distributed machine learning and anything where there's collaborative machine learning, or even machine learning in a MapReduce model, where you're taking it and just using wasmCloud to be the connective tissue between you and the greater forest. Well, that's great, Steve. That's awesome. Let's go ahead and transition to your second demo today, which is the I'll go ahead and do the introduction. I know you've been working on this one.
Yeah. So as one of the first attempts to figure out how to connect wasmCloud to machine learning engines, I created a Python capability provider. Whoops. Here it is. And so this is it's not a true capability provider. It takes a few shortcuts that are less secure and probably less stable, but it was a quick way to connect wasmCloud actors to machine learning code. And so what it does is you can send a message from an actor to the provider, And this is actually not specific for machine learning. It's you can invoke any Python code. And right here on the screen, this is from the README in the repository, which is now in the examples repository, wasmCloud examples. An actor, if we want to call this a factorial function, we can pass a parameter here. We're just passing a number, and we're getting back an integer response from this function. And this is the Python implementation that runs on the capability provider. We can pass all kinds of objects. We can pass primitive types or lists or hash maps, and it gets converted to Python objects and read in, passed as the argument to the function, and then the return value again gets converted back to a REST object. And this will also work after we add other language support for other languages for actors. Feel free to play around with it. There's a bunch of caveats in the README. One of them is that you have to have the Python environment already set up on the machine, on the host machine, before you can invoke it. And that breaks the portability that we have for providers. You can't just tell any host to start a provider from an OCI reference unless it's already got some environment variable set and your Python code already installed there. But feel free to play with it and let us know what you think.
Steve, so I have just a clarification / question, mostly clarification. So this isn't, it's not a way to write capability providers in Python. It's a way that you can have actors call Python functions. Is that right?
Well, you could write a capability provider in Python with this, absolutely. And then the one difference is it doesn't have a set interface API like our other providers do. The API is you pass the function name and the argument. So it's kind of a generic way to invoke the provider, but you could put any code you want there. And because it does have a pre-installed Python environment, it means you can install TensorFlow. You can install the Intel extensions for TensorFlow or any other Python library and run it. So yeah, you could use it to take even existing Python code and have wasmCloud actors call it. But there are, again, caveats to portability and security.
Interesting. I think this is another neat example, Steve. Thank you so much for all the hard work on this. And, I think you're, kind of tenuous connection here to machine learning with all the focus on, R and what people do, I think is interesting as well. Well, does anyone have any questions on this before we move on? All right. Well, thank you again, Steve. And we'll watch for the demos to be checked in. Let's make sure we drop a couple links into chat on that. And kind of want to open the floor. Anybody else have any demos or anything that they wanted to share today? Okay, I'll do a quick community call out. I know a lot of people were able to attend the last We Love Tech event from our great friends at Red Badger. And I'd call out that they've got a new We Love Tech event on the way featuring Nats. So this is next week. This is Wednesday, April the 20th at their HQ in virtual. I'll drop the link in the Slack And we'll, of course, tweet it again to get anyone interested. We obviously also love not only tech, but Nats and are huge fans. I think that Derek and the team are going to be talking about Jetstream and some of the other exciting new things that they have. And of course, all of these capabilities and features are available in wasmCloud as well. One of the many reasons why we've elected to partner with Nats on the development of wasmCloud. Any other community callouts that people wanted to make today? Great. Any open issues or development opportunities we wanted to discuss? All right. Well, we'll go ahead and wrap it up here. I'm going to go ahead and stop recording, but as usual, we can hang out. Everybody have a great week. Happy wasmCloud Wednesday.